Hello and welcome. My name is Tom Sullivan, and in this tutorial I'm going to demonstrate how to estimate the hypotenuse of a right triangle without the use of a calculator. That's right, by the end of this short video you'll be solving Pythagorean theorem problems in your head without a calculator. And your answers will always be within about 5% of the solution provided by the Pythagorean theorem. Let me introduce the three simple steps that you'll need to do this. First, you'll form a fraction using the given legs of the triangle. You'll then find a factor, which I call the approximation factor. You'll get that from my slide rule. Then you'll formulate your estimation by simply multiplying that factor times the base. And we'll talk about how you do that. So let's start with our very first example using 82 and 100 as the given lengths of our right triangle's legs. And we'll go through our steps. Step 1, we'll form a proper fraction, which is simply the smaller number divided by the larger number. In this case, 82 divided by 100. 82 100ths, which will convert to a decimal, 0.82. And it's this decimal equivalent that we'll use on my slide rule to find the associated approximation factor. Alright, so here's my slide rule. The decimal equivalents of the proper fractions are along the top here. 0.32, 0.57, 0.75, 0.91. The approximation factors are in the middle. They run from 1.0 to 1.4. And for now we'll ignore the factors on the bottom row. As you can see from the green arrow here, the 0.82 we found in the first step fits along the slide rule right about here, in between 0.75 and 0.91. And now that we know that's where it fits, we look down below and get our approximation factor from this box, which is 1.3. Now for step 3. Using our 1.3 factor and our base of 100, I refer to the larger of our two numbers that are given, the two legs that are given to us, I refer to the larger of the two as our base. We'll multiply those two numbers to formulate our estimated hypotenuse value. In this case, 1.3 times 100 gives us 130. If we were to use the Pythagorean theorem to solve this, squaring 100 and adding it to 82 squared and then taking their square root, we would get 129.32. So our answer is within about 0.5% of the calculated value. So let's jump right into another example to give you a better feeling for how this works. Are you ready? Again, to solve for its hypotenuse, you're given a new triangle. In this case, we have leg lengths of 45 and 100. I'm using 100 because it's simple, but you'll see later it really doesn't matter. I've included the 3 steps you need to follow on the right here. Remember, the fraction has to be a proper fraction. Once you get it, convert it to a decimal and put that on the slide rule wherever it happens to fit. Once you find that spot, look below to get your approximation factor, and then simply multiply that times your base, which is again 100. That's the bigger of the two numbers. And you've got your answer. Did you get it already? You can pause this video right now if you want to give yourself more time to work on it before I reveal the answer in the next slide. If not, let's go to the next slide and double check your work. All right, starting with our leg lengths of 45 and 100, step 1 says to form a proper fraction, 45 divided by 100. Then convert it to a decimal of 0.45. Next, we slide that 0.45 along our slide rule to find where it fits. In this case, it's where the green arrow is, about halfway between 0.32 and 0.57. Once we find that point, we look down below, and underneath we see our approximation factor, in this case, is 1.1. Our third and final step then is to multiply the base, which is the bigger of the two numbers, 100, times our 1.1 and get an estimated value of our hypotenuse of 110. Interestingly enough, if we were to use the Pythagorean theorem to solve this example, we would get 109.7. So once again, we're pretty close to the approximation in our slide rule that would give us the number produced by the Pythagorean theorem. Now I'm going to guess at this point, if you're still watching this video, you're probably wondering what happens when the decimal equivalent we come up with is either close to or perhaps even equal to one of the transition points. Those points where we transition from one approximation factor to the next. We call those the transition points. And in fact, this question needs to be addressed because I told you earlier that it's okay to estimate or round off your decimal equivalent when you're converting from your fractional value. So I mean, if you're somewhere around that transition point, especially if you've estimated or rounded off, how would you know whether to use 1.1 or 1.2, for example, if you're right near 0.57? So this is a great question. But instead of giving you the answer, I'm going to do one more example. And I'm going to use the most famous triangle in the world. So our given lengths are, you guessed it, 3 and 4. And so even though you already know the hypotenuse's length in this case, we're going to walk through our steps and see how we come out. We'll start by forming our fraction, 3 divided by 4. We'll convert 3/4 to a decimal of 0.75. And then we'll see where it fits. Oddly enough, it fits right on top of a transition point of 0.75. So if we use 1.2 times our base of 4, we're going to get 4.8. And if we use 1.3 times 4, our base of 4, we'll get 5.2. In either case, you'd be within 5% of the real value, but there's a much better answer to be had here. And that is to simply split the difference and use 1.25, which when we multiply times our base of 4, gives us exactly what we already knew was the answer, and that's 5. And there's a very good reason for doing this. This value along the bottom is the exact approximation value, factor value of 0.75. So that's the reason that we transition, is because we're halfway between those two numbers. All right, so to summarize here, the rule for approximations is that when you're on or near a transition point, use an approximation value that's halfway between the values on either side of that point. And as I mentioned earlier, this allows you to be a little sloppy with your conversions from fractions to decimals, because if you're in the middle of the range on the slide rule, it really doesn't matter. And if you're near a transition point, you simply split the difference, use the value that's halfway between, and that improves your estimate. Ain't that just sweet as pie, spelled P-I? Simple, easy, accurate. And with just a little practice, you'll have the slide rules numbers memorized, and you'll be doing this in your head without a calculator. This ends my tutorial. I certainly hope you've enjoyed it. If you're interested to know more about my slide rule, the relationships of a right triangle, the Pythagorean theorem, how all this relates to electricity, or if you just want more practice using this method with the aim of learning how to do it in your head, please visit my website, theelectricclassroom.com, all one word, as I hope to have a more detailed course available for you soon. See you again, and thanks for stopping into my classroom.